And I do believe that everything is working and I am live. Could test it, but clearly not here for that. So, welcome. I'm the Chronic Phoenix, and today we're back on the Platformer Project, also known as Destination Level Design, a name I am not changing, even though it's, how shall we say, not very descriptive of the project anymore. Well, ish. The reason I'm not changing it is because it should be descriptive of the project. The original goal was to learn level design by creating a platformer. That got wildly out of hand, and we are nowhere even sort of on that one. So, the reason I'm not changing the name, though, is because, hopefully at some point I'll actually get to that. The idea is still eventually to use this to learn level design, study it, experiment with it, whatever. Get around to that eventually. And then maybe if I do that, I'll actually make a game. Who knows? So, today, I'm actually going to start off not rambling. It's weird, especially for anyone who used to watch my streams, but it's just not going to happen. Sort of. I mean, I'm already sort of rambling, but ignore that. What I'm going to do today, at the start of this, is just make a simple script so I can actually show off everything I've been working on. That's right, I'll actually be doing some level of work on stream. It's a first for me, and boy, it's not going to go well. Probably. But here we are. Okay, so what this script is basically going to do is just interact with the player and some new shader functions that I've been working on, specifically the twist functions of the shader, which I have made leaps and bounds on in the past 2 days. I made shocking amount of progress yesterday, which was surprising because, boy howdy, I had gotten the vaccine the day before, and wait, what day is today? I don't know time. Time is irrelevant to me. Yeah, the day before. And it was hitting me hard. So, first we're going to need some sort of reference to the player's renderer so we can grab the material and send values to it in order to manipulate it, and the shader that's attached to the material. So, we are going to need a material. Okay, so we'll have a public renderer. We'll just assign that because this script is not going to stick around. It's very temporary, but just assign that myself manually. Then we'll grab the material from that, and then we can start manipulating it. So the question is, what are all the values that I need to update / manipulate on the shader? I know the first one is going to be a position for the twist. So I'm going to need the twist origin point, the twist direction, and the twist axis. All three are very important, and then I'll need some other values, but those I can start with. So let's see, mat.set vector. So we're going to need vector 3s for all of these. The first one is easy. The question is, what are the names of all of these? Let's look at this shader. Are they named simply? They should be. Yeah, just, okay. That's easy then. So first things first, twist origin, and that will just be set to the transformed position of this rotation point, the object that this script is attached to. because I want the idea for this script is basically to have a point in space that is visual that people can look at, and that will signify the sort of the point in space that the player is rotating around, or in respect to. I was going to try not to ramble on nearly as much as last time, because an hour of straight talking murdered my voice and my body. It was brutal. So I'm just going to do this for now with twist direction. There's a weird thing with twist direction, and I'm not sure how I want to grab it for something like this script. For future actual interaction, gameplay-wise, with this shader, twist direction will be easy to assign, but for this, it's going to be a little bit complicated because it has to keep updating in real time, so... Yeah, I'm just going to leave that as it... Oh, actually, what I could do is change this to... This will be more interesting, although that one will still... Twist direction will still have to be defined. Twist axis will now be based on the transform.up, or the upwards facing direction of the rotational pivot object. That way I can rotate it in real time and we can see the twist interacting with that, changing dynamically as it goes. Twist direction doesn't have to be changed dynamically, but we'll get into that. Okay, so we have those three things. The next thing to do is going to need a public int, and it will be rotations equals 1. Well, equals 0. Map set. I think it's actually a float. There's no reason for it to be a float, but I'm pretty sure it's a float. And I'll get into all these values later. But okay, what else do we need? So we have axis, origin, direction, rotations. Right, we need length. And those three we don't need right now, just need length. What the? Oh, it's just twist length, okay. Okay, cool. 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 Everything's updated. Now if I go back to the scene, this script is assigned, so now I just need to assign the player's renderer. And this should work. cancel out that movement script, and here we go. Let's see. Boy, look at that. Nothing happened. Perfect. It's exactly what I wanted to see. Now, if I start... Wait. Oh, right. One thing that I want to do is add on a second object. Doesn't really matter. This object will just give us a representation of the orientation. Something like, well, that's, I don't know. Something like that. Easy enough to see. Doesn't do anything. Okay. Now let's do this again. Okay, so if I add in one rotation, and I just start moving the player around, what you will see is as the player moves past that point, it rotates. One full 360-degree rotation, starting from the top down, using the vertex, well, the distance between the vertices and the object itself along the vertical axis. So it uses some trigonometry to determine the actual position along that specific axis that each vertex is, because actually, if I just rotate this object like so, and then this should work. No problem if it doesn't. There we go. So, as you can see, even if the orientation of this little rotational object, the way that it's pointing, is the axis upon which the player's, well, everything will rotate. And so the reason that you need trigonometry for something like this is because you need to determine the actual position of each of the vertices along this line right here. Because you can't rely on just X and Y. And this works in 3D space, so if I were to rotate, or should work in 3D space anyway, there's no real reason to for this project, but it does, and that's what matters. So if I were to rotate that off axis, so it's pointing up at some weird diagonal, and I move the player, it should, yeah, rotate in a very bizarre way. But rest back here. So that is the sort of really basic functionality of the twist function to this shader. But it gets a lot better. There's a lot more ways in which this actually functions. Let's try something simple though. Let's just go 90 degrees on the Z and make sure this works as intended. Does, look at that. Incredible. Now it's rotating around the x-axis. Fantastic. Okay. Now let's get into some more interesting stuff. So there's a lot of different things that you can actually do with this, but some of the key functionality is, well, the ability to define a point in 3D space, define a axis of rotation, and then how many times you want to rotate, and the length of that rotation. So if I were to change some values over on the, oops, that's not what I want to do. If I were to change some values on rotation point, like rotation length, it will now take 2 times the amount of distance to do that one full 360-degree rotation. So if I grab the player, move it past. Oh wait, let's make that rotation a little bit more sensible. You can see it starts rotating all the way down here rather than right next to the point, and it ends way up there. If we make a more drastic change to that, it's going to be rotating down here already, all the way down here, and a very gentle and pretty smooth looking rotation actually. Beautiful. Just beautiful. Now, an interesting thing that you can do with this that I added in is the ability to have the ability to have off-center rotations, so you can get a corkscrew effect. And if I just use the offset like so, and move the player again, you'll see it is rotating. It's a little bit hard to see in this instance, but it's rotating around that point. It's never actually hitting it. Well, that's a weird angle. And the purpose of this is just for animations. That's all it's good for. But it should create some really interesting animations. One idea I'm thinking of is to have sort of like twisty glass tubes that the player can then animate through. I wanted to do that before, but I had no idea how I was going to animate it. But now, if we just do something like that, and I don't know, that. And let's make this offset more sensible. Ish. Sure. And let's move the player. Yeah. So if you were to imagine like a glass circle-y tube, I guess, could be interesting. Double up the rotations. Oh, that gets weird fast. Sure. Oh, I should change the rotation length. There we go. Now, you know, as you see, there's some issues here that could be solved, well, solved a bit by having more vertices on the cube itself. That would allow it to follow a cleaner, smoother path. But all of these animations will be happening pretty quickly in motion, and this is sort of a really bizarre use case for this anyway. But always has its limitations. Honestly, that script and the whole rotation point itself didn't really work out as intended. Sort of useless, but here we are. It is surprisingly hard to show off all the different features in this script. I really should have thought about this beforehand, but you know, thinking beforehand, not really my specialty. Oh, okay, that's weird. There we go. Yeah. So you have, you can change the scale of the object, you can change the offset of it. Ooh, that's wrong. You can change the offset of it to get some of those more interesting off-center rotations. Then you have your twist axis, origin, and direction, like I stated previously, to get, well, any sort of rotation that you want. Now there are some... When I was designing this, I had an idea in my head for how this was going to work. And the idea was you define a point space, define the rotation you want, and then as you move past it, it rotates. But there's a key issue with that. And if I just, you know what, I'm going to get rid of this. That's pointless. It's just not helpful. I'll just do this manually. If I define a point such as -2, that should be somewhere around there. say one rotation. Oh, that's, oh right. Got update twist direction. And then I move the player, yeah. Right around here, it is doing its full rotation. But, as you might notice, it looks very weird. As it's moving across this point. Doesn't look like the corkscrew shape that I would want it to look like. It looks like it's just folding in upon itself. And that is because the way the system works is it measures the distance from each vertice along the axis. But it has to measure twice. So it has to measure up from the bottom along the axis of rotation. So if it's rotating, along the y-axis, measures from the bottom up in order to get that corkscrew sort of shape. But then it's also measuring along the direction of rotation, or the direction to the point in space where it's going to rotate. And that's two sort of what are known as lerps going on at once. And a lerp is basically just a smooth transition across a specific period of time. Or in this case, distance, because time is irrelevant in this case. So as the player gets closer to the point in space, that's smoothly moving the value from no rotation to full rotation. But because it's doing that on both axes, it is sort of confusing itself and getting all wonky. Yeah, that's a perfectly reasonable way to describe it. Yeah. And there's no real good way to fix this, because the problem is that normally if the rotation was up, let me just change that value to make this all make just an ounce more sense than it does. If the player was moving up, as you can see, so the point in space that's rotating around is right here, and it's rotating around the y-axis. Now, this works beautifully because all of the vertices are, well, the orientation of the direction and the rotation are aligned. So it's only rotating the vertices that it needs to. All of these are not being rotated, only these are. Now, if that happens going where the two directions don't align properly, let me just update that so I can. Should have drawn like graphs or something. That would have been helpful. But if I change the direction and the origin to something like that, then move the player. So as you can see, if we do a top-down view, the vertices that are being rotated are just these, much like as it was approaching vertically, only the top little section was at first being rotated. That's the same here, because the point in space is this way and it knows that it's moving towards it. So only the vertices on this side of the object are actually being rotated. But because it's rotating on the vertical axis, it gets weird because it's just folding in on itself. And there's actually no way to fix this because it just fundamentally doesn't work. I mean, you can do it like this, it's fine, but it looks weird, and it's not the look that I wanted at all. It's been a while trying to fix this, but it is a literal limitation of how this works. Like, it worked in my mind, but I hadn't really thought through the process, and there's no way that this sort of system works in the way that I wanted it to work. So rather than trying to make a perfect system, which I am far too guilty of trying to do, I create a secondary sort of fallback system, and that is, wait, what's by vertex? That should be, I think I broke something in the shader. True, false. Sure. Yes. It's false. Goes down from... Yes. Oh, also, I don't need this anymore. What have I done? You know, I'm positive that this was actually working before I started streaming. Okay, so the... Very, very interesting. Very, very interesting. So this twist by vertex Boolean or switch is supposed to change it from rotating based on the distance from the point in space where it's supposed to rotate from each vertice, using trigonometry to measure it on the axis, because if it's rotated, obviously you can't just... However, when it's off, it's supposed to use just the raw position of the object itself. But I've screwed something up. Okay, I know what I screwed up. I just don't know what I was thinking. So what I need is object position. And, do I need... Yeah, I need a transform... Wait, do I? Presumably. Okay, well, there we go. Now you can see it, you know, properly rotating, as it were, looking like the actual sort of spiral shape that I intended it to look like. The problem with this, however, is that it doesn't take into account scale of the object, and I thought I changed it somehow so it did, but now I'm thinking that it never did, and I simply broke it, thinking that I had fixed it. This is a problem. How to change this is the question. Specifically, the sort of problem with this is that if you were to change the size like this, the point space is over here, but the player object, because it is just measuring the distance based on where it is in space, being the center of it, it won't start rotating until it's like right on top of it, which obviously, since this is the point space, you want this side to start rotating first. Yeah, I didn't... Interesting. Very interesting, really. It's complicated and problematic. But suffice to say, that is the solution, which I presumed was much better before I started streaming, to this problem. Rather than measuring based on vertices alone, you measure based on the object itself, just its position in space. But it should be adjusted for the scale. So, what did I do to make that work? I know I did something for that. I know I was measuring based on the spacing, but I modified it somehow to work. Twist by vertice, fallback delay. Oh, did I? No. Yes. Strange. Well, I'll figure it out later. Suffice to say, we'll get there one day. Okay, so the first, I'm just going to dive into and start trying to integrate this into some of the movements that the player makes, because that's sort of the entire purpose of this thing, and I can fix the shader later or make adjustments as are necessary. The first thing that I want to add in was if we just go to the player movement core, the player has this dash ability. You can see it happening right there. They could do it whenever in any of the 8 cardinal directions. And what I wanted to do was add sort of a, I want the player to sort of squish down while it's doing that and then corkscrew. I just think that'd be interesting. But only while it's in the air. While it's on the ground, I want it to sort of flatten to the ground and then do a vertical, like, spin, a vertical corkscrew. As if it's like spinning / sliding across the ground. And that's going to be the first one that I attempt to add in, because I think it'll look really cool if I can get it working. And the system should support that. Let me just play around with the shader and make sure that it will. It would be a non-twist by vertex. So if the player just moves, be like that. What happens if I shrink it though? Right. It doesn't adjust for the size difference, and I would really like it to. Wait, it should be adjusting for the size though. What's going on down here? Directional difference from the position of the object. Twist axis. Wait, position of the object. Wait, what did I do here? Wait, do I want that? No, wait, what I actually want is... I think what I want is this. I want to account for the basic scale and offset adjustments first. I think. So if I do that... Oh. Oh, right. Right. No, it can't. This grows more and more problematic by the moment. Okay, whatever. We'll leave it. It's not really that important. It'll just look more twisty this way. So, first things first, I just need to go to the player, and where do I want to add this in? I think, is it just connect? I know one of these scripts already handles stuff with the material, but I'm not sure which one. Is it actually a script? No, it's must be player, yeah. There it is. Okay. So I'm already doing stuff with the mats for all the different squish and other stuff going on here. So all I have to do is modify or add in changes. So let's see. So here's the dash. So I just want to add in. Okay. The most brilliant comments you will ever see. This code is so well commented that you could not hope to. It would be impossible to read this and not understand what's going on. Like, it's brilliant. Look at it. Dash, shader stuff. There's a comment somewhere else, I'm sure. Brilliant. Brilliant stuff. Okay. So, mats 0 dot set. So, I just need to set a bunch of vectors. Actually, I can just copy this stuff. This is all the information I need, more or less. Okay, so no, I don't want any of this stuff. So I want transform.position plus new vector 3. This will define a point in space out in the direction of the dash, and the dash takes the player a distance of 5 blocks, so I want the rotation length to be 5 because I want the rotation to cover the entirety of the dash. And then mats 0 set int. What's it called? I don't want this to be a vertex. Twist by vertex. So twist by vertex would be false. Twist by vertex 0. And if you're wondering why a Boolean value is being set with an int, it's because that's how the system handles it. 0 is false, 1 is true. Okay, the rotation will be, I don't know, the actual number of rotations doesn't matter, so let's do 2. That'll be up in the air, really. Vector 3 dot up. The twist axis because we want it to be vertical. And then, oh right, I need a position, so force equals input dot normalized. Yes. So not so input dot normalized times by 2 point. Let's do this manually for now. I'll adjust it later. 2.5f, because we want it to be halfway along the distance. Wait, why doesn't that work? Oh, input.normalize is a vector too, isn't it? Okay. Simple enough. Just convert that. And finally, the twist direction, which is the direction of movement, which is just input.normalized. Simple enough. Okay, so this should work. The only problem with this system is that basically it should turn off after the dash has been completed, because the only problem with this shader is that once you define a point in space, that point remains and the shader will keep track of it. So if you were to dash and cause a rotation, that point space would remain. If you were to just walk backwards along that dash line, you would start rotating as if you were dashing. And currently there's no good way to read when a dash is over or any movement that would require rotation. That'll have to be a system that I build into place in order to accommodate these new animations, but for now this should work fine. So let's try this. Okay. Right. That should be that. That should be that. And that should be that. Cool. Ah, look, it's sort of brilliant. What do oh, I'm zoomed in. Okay, there we go. Oh, I should also make this area longer. Not what I meant to do. There we go. Ah, the level editor. Even for running tests like this, just having the level editor ready to go feels so good. So very good. It makes everything super easy. Oh my gosh, look at that. It's brilliant. Incredible. Although, do I want it to rotate I might want it to rotate the other way. Let's change that. I think if I just change the axis, it should invert the rotation. And we'll try this. Oh, I see what's going on. Okay. Vector 3 dot up times how do I want to do this? Change that. It's very hard to tell if this is actually working as intended. Can I do something about that? Ah yes, force multiplier. Let's just cancel out that bad boy. Yeah, I like how that's working. Now, what I want to do is, along with this, I want it to sort of flatten out a bit. And how exactly am I going to do that? I think just adjusting the scale and offset should be fine. Mat 0 dot set vector size. Ooh. not zeros. That would be bad. Okay, I don't think offset is named offset. No, it is. Oh, right. Because of how naming conventions work, yeah. Because I think offset is an actual value in materials or shaders, and so you can't just name something offset. Something like that, anyway. I mean, this is a terrible naming convention anyway, but here we are. There we go. Look at that work. It's beautiful. Okay. Right, I need flip in place. Where do I set this? Color shift. Interesting. It is getting changed, but why is it getting changed? Okay, well, I'll just do this in the shader. Offset needs to be modified by this value, so multiply. This should work. In the exact opposite way as I intended. Precisely what I thought would happen. Okay, we'll do this part in code. There we go. Hey, look at that, it's beautiful. Now, the only problem, of course, is that the player does not reset once it reaches the end, and the question of how to do that is, not sure. I don't know what the best way to do this would be, because I need accurate information on when the dash ends. Actually, I should be able to... I have a system potentially in place for this already. Identifier equals dash. For mcore.ef handler dot external forces contains oh, how does external forces contains even work? I added this feature specifically for something like this, but I have no idea how it works. Oh, it checks the identifier and the force. Okay. Is the force ever modified? Well, let's just try it. Okay, so I want to pass. What do I? So I pass in an external force. So I'm going to record the dash force. External force is a custom class that keeps track of a bunch of information. And this function, external forces, contains, so any object that puts a force onto another object compiles a copy of this class, or not a copy, but a instance of this class called external force, and then fills it out with information, be it an identifier, a force, a direction, and a distance. So you basically say what is the direction that you want to push that object, and what is the distance over which you want to push it, and then it will sort of calculate that out accordingly. And everything that applies an external force to one object, all of those external forces get added to a list, and the next time that object moves, it calculates, it sort of adds together all those external forces, finds out which ones are sort of used up, where it's moved the distance, or attempted to move the distance. And yeah, because like if you have an external force that's pushing you 5 blocks to the left, you hit a block 1 block to the left, that external force should cancel out because it, there's a wall there, your movement is canceled. Anyway, dash force, we'll just call it dash force, because sure, why not? I have absolutely no idea if this is going to work, but hopefully it does. That would be super simple. Right. If external forces of M core or movement core on the player contains dash force, or doesn't contain dash force, then we want to reset a bunch of stuff. We don't have to reset everything. We need to set rotations to 0. That will cancel out any rotational value that is tied to moving past that point in space. And I want to reset size and offset to be 0. There. That should work. In theory, provide external forces contains actually functions as intended. Which I have every reason to believe it does not. Never mind. Look at that, it does. Now, I would like it if it was not so sudden, if it like transitioned smoothly into the rotation and then out. And I actually do have a system for that, but it's not tied into the shader yet. And that system is this squish vector. It is used for a dynamic tunnel system. So if I just spawn in some of those, you can see it in action. Level editor. All the tunnels that are parented together join into one. It has a similar vertex displacement script as the player in setting that up, and then as the player... Oh, that is wrong. In completely the opposite... How did I break this? sense. What I'm really confused by right now is where this flip value is getting set. It's clearly being set by something, but I have no idea what it's being set by, and it's a problem. I'm being set in here. Oh my god. Where is this being modified from? Well, I have absolutely no idea, but you can see this whole system working apparently in reverse. So if we zoom in on this bad boy, as you can see, as the player moves into the tunnel, it gets squished. It's just getting squished in the wrong direction for some unknown reason. And see, that value flip is supposed to flip all the different values so that it works appropriately. But it's not. Like, it's getting flipped, and I have no idea which script is actually interacting with that, which is the most confusing part of all of this, because it's some script interacting with this, but what script? I got nothing. Yeah. On the bright side, you got the little dash slide in, and honestly, I think that is a much better thing than just, you know, dashing with no animation. I really like how this looks, and this is one of the things that I want to add in. I mean, there's still plenty of adjustments to make to it, and I do want to smooth in and out like the tunnel should be smoothing in and out. As you can see, it gets smaller on this side and then sort of smoothly transitions into the wide part. Of course, that should be flipped so it, you know, actually visually matches up with the tunnels. But yeah, so I want to do that same thing, but on the slide, and it will smoothly move into the slide and out of the slide, and it will look fantastic. It will look super cool. But I am actually going to leave it there for today. Didn't really get as much done, and this was all much more confusing than it had any right to be, but my throat and body can only take so much talking, so I think an hour for these streams is a pretty good place to cut it for right now, and yeah, hope it was in some way entertaining, and thank you for to everyone who showed up, or to anyone who's watching the VOD. It means a lot. And yeah, till next time.